Sample problem 11-05. Four 4-Newton forces, A through D, act on a 3 meter by 4 meter piece of plywood as shown below. Rank the magnitude of the torques due to the 4 forces about point P. So we see right away our rotation axis is this, and we need to compute each of the different torques. The easiest way to rank them is probably to just compute them. So we'll start doing that one by one. So let's take A. So we'll look for the torque. The torque due to A. And to do that, we'll want to do what's called the line of action, which is just the infinite line that contains the force vector. So it's this, that line. And the reason we do that is that we know that torque A will be force A times the perpendicular distance that A has between the line of action and the point of rotation. But this is a little goofy, and maybe it's weird they called that A, because right away we see that the line of action passes through the axis point. Right, we can see that right here. There's our line of action, passes right through P, and therefore the shortest perpendicular distance is 0. So A has no torque, or at least has a torque of 0. If we look at B, we're going to say, well, the line of action for B is parallel to the one for A, and the R perpendicular is going to be this line, the perpendicular distance between the line of action and the axis point. And we can see that that line is the hypotenuse of this right triangle, and the sides of the right triangle are each 2. So this distance here, our perpendicular B, is going to be the square root of 2 square plus 2 square, which is 2 root 2, a number somewhat bigger than 2. It's about 2.8 or something like that. All right, so the torque for B is going to be the force of B times the perpendicular distance for B, which is the 4 newtons times 2 root 2. If we look at C, this is getting kind of complicated, so I'm going to stop and clean up a little bit. All right, clean up a little bit. If we look at C, the line of action for C is that, and the shortest distance between that line of action and this point is this segment, which clearly has a distance of 2. And so the torque for C, which is the force of C times R perpendicular C, is 4 times 2. And now it's almost sort of, I don't know if trivial, but it's sort of done. If we look at D, D has this line of action, this vertical line. The shortest distance between that line and the pivot point is this side. That's R perpendicular D, and that is also 2. So if we look at our conclusions here, we end up with that 4 times 2 root 2 is definitely bigger than 4 times 2, which is definitely bigger than 4 times 0. And so we're left with that B is bigger than either C or D, and then each of them is bigger than A. So that would be our rank ordering.